Hey and welcome everyone. Thanks for stopping by onto episode 4 of the AKS Zero to Hero learning series from myself and Gregor. Today, I'm going to show Gregor how to actually deploy an AKS cluster using the Azure Portal.
Cool, looking forward to it. So we're not actually deploying a application, we're just going to set up an empty AKS cluster.
Yep, exactly. Got to start off somewhere. So basically what we're doing here is building the foundations of a house, and then we can actually build on top of it. Without that, it's never going to work.
Cool. I'll just ask questions if I've got any as we go.
Cool. So I'm just going to open up the Azure Portal. Just like that, magic. Thanks to Stream Deck. So obviously here, everyone should be familiar with the Azure Portal. If you're not, it's portal.azure.com. Usually you're welcomed with this homepage. Sometimes you might get the dashboard. It all depends how you set it up, but most people get the homepage. Here I've got some services that I use a lot at the top. So obviously Kubernetes is up here. But what we're going to do is click Create a Resource. If I click the right screen, that one there. And then we're going to type in this box AKS. And we're going to go down to Kubernetes Services. Here we then click Create. And then we get to this sort of screen that most people are familiar with. Any Azure resource, when you set it up, you've seen a screen very similar to this one. So we're going to pick a subscription. So I'm just going to use my PixelRobots.co.uk subscription. Little hint there, if you want to go read about AKS, go and have a little look at my blog. There's the URL.
Nice plug.
We're gonna create a resource group for this. So we're going to do it RG for resource group, AKS 0 to Hero.
Okay,
nice
so
and simple.
Nice naming convention straight away.
Yeah, makes it easy to know that it's a resource group. It's going to house my AKS stuff, and it's all about the 0 to Hero. So now we need a cluster name. So all we're going to do here, I like to put AKS in it again, and then we can do 0 to Hero once again.
Is there any limits on the cluster name size or anything like that?
So you just got to think about DNS names and everything. So it just sort of has to be a certain length to hit within DNS limits, and obviously only letters, numbers, underscores, and hyphens. So no full stops or anything like that. And obviously here it has to be unique within the current resource group. So you can actually have the same cluster name in your subscriptions, but it has to just be unique within the resource group. And then we're going to pick the region here. So if we just find West Europe, will do. I would choose UK South, but it's more expensive, so I'm going for West Europe because I'm tight. Then we've got availability zones. So do you know what availability zones are, Gregor?
I do, but some of our listeners might not. So tell us all about them.
Cool. So availability zones. So in an Azure region, they sort of have these zones which can be represented by physical different data centers in that region, sort of slightly separated apart, but they'll have independent cooling, heating. Well, maybe not heating, but you know what I mean. Cooling, electricity, everything like that. It's all separate. So most Azure regions have 3 zones. So this West Europe has 3.
In my head, I always think of 3 different buildings in the same sort of like area, but I always visualize, I think, building 1, building 2, and building 3.
Yeah, it's the best way to do it. They're usually separated enough, so if something happens in building 1, it won't affect building 2 or 3. They're usually supplied by different energy providers and stuff like that. So if there's an issue with one energy provider, then it won't affect the other 2. So what I always like to do is basically max it out as many as I can. So I'm going to use all 3 of those. So if one zone does die, my AKS cluster is going to stay up in the other 2 zones until zone 1's back.
Do you have to pay more for having 3 zones as opposed to 1 or 2?
No, because, so as you can see here, it says you should, for production workloads, have at least 3 nodes. So by having those 3 nodes, just spreading them out between availability zones, so you're actually only paying for the resources in each zone as you would normally. So it's all fine. One good thing to note about this availability zone section is it also spreads your control plane. So earlier we talked about the master and the control plane. By setting your availability zones here, it actually spreads the control plane out over the different zones, which gives you a better uptime SLA sort of thing. Well, not the actual paid for SLA, but you know what it's like. Then here we have the Kubernetes version. So we have quite a few versions. You'll see we've got the newest versions at the top. So they're the 0.19s, and then the 18s and the 17s. 16s are still currently in here. Normally, you would only see the first 3, but because over the Christmas period, Microsoft decided they're going to give a longer sort of grace period for the older versions, because not many people actually make changes over the Christmas period. So they've left these ones in there, but they will be going soon. So for this, I'm just going to use the default one, just because it's the default. Yep.
Why does it not default to the latest? Is there any real reason for that?
Well, with Kubernetes, they change a lot of stuff very quickly. If you've got something working on version 18, it potentially might not work on version 19. So they go for the one which is in the middle. So they support usually one above, one below, and so the middle obviously makes sense. So then we have the primary node pool, which is also called the system node pool. It would be nice if they put the names consistent, but So all we have here is the VM size. So by default, it's always the standard DS2v2. Just gives you 2 CPUs, and then I think it's about 7 gig of RAM per node. You can obviously change the size and pick any size you need. And then we have the node count. So if it's production, like it says above, at least 3 nodes. But because we're just playing around, I'm just going to drop that down to 1 node and then move on to the next one.
Would that mean 1 node per? Is that 1 node deployed to each zone?
No, that's actually just 1 node deployed for your cluster, and it could end up in any of the zones. We have no way to control which zone it's going to end up in. But what gets deployed on this primary node pool or the system node pool are the Kubernetes system pods. So you get your core DNS and all of that stuff that we talked about in previous episode. So that's why you should have 3, because if these nodes die, then your cluster dies. So very important nodes, but because we're testing, we're only going to do 1. Production, use 3. So next we go on to node pool. So that's our system node pool. As you can see here, it actually calls it system. So this is what we've just created. It's called agent pool. You can change the name if you really wanted to. There's no need. And then it's called Linux. It's using Linux because the system node pool has to be Linux, because all of the Kubernetes system pods only run on Linux. The node count, the size, availability zones, the max pods per node, which is 110. So that's how many pods you can run on each node. When you create this through other methods, it's usually defaults to 30, but in the portal, it always goes 110. So we could actually click on agent pool, and then we can actually change the name, change the zones again, change the size, but we could also put how many pods we want on, and then we can update that. I'm not going to update that, so I'll just hit cancel. Then we have an option called virtual nodes. So virtual nodes utilizes Azure Container Instances, which is a serverless resource from Azure. So do you know about container instances at all? No,
not really. Cool. No.
So in Azure, you get your AKS, but then you also get the container instances, which is as I said, serverless. So you don't get to play with any VMs or anything. Microsoft look after all of that, and you can spin up containers whenever you need for as short as period as you need. They are built per second as well. So they're perfect for if you're scaling out, doing a bit of data analytics, you can just scale up a pod into your Azure Container Instance. It runs for a couple of minutes or so, and then you take it down, and then you only pay for the minute you're up. So it's awesome. And with Kubernetes, you can actually create a virtual node. So it's not an actual physical node, but It's a virtual one that uses Azure Container Instances, so you can burst into that and then pay per second. So you don't have to have a node up and running where you're paying the hourly rate for that node. So that's really cool, and it's so simple to set up. You just tick a box. But in this demo, we're not going to worry about that just yet. The next one here is enable virtual machine scale set. So this is actually enabled by default if you're using availability zones. Before, you used to be able to do it in availability sets, which is an older technology to do with VMs, and that now it's all virtual machine scale sets. It's so much better. So yeah, you'll probably, unless you don't use availability zones, you'll never be able to turn it off. And I highly recommend you always leave it on. Cool. Next up, we have Authentication tab. So there's sort of two different ways you can get your Kubernetes services cluster to talk to other cloud resources in Azure. So like Active Directory, Key Vault, networking, and everything like that. You can either create your service principal yourself or do a system as assigned managed identity. So with the service principal method, you have to create it, you have to update the password when it expires and manage all of that. The system assigned managed identity is all managed by Microsoft, and they deal with all of the password updates and everything like that. So definitely go for that method if you can. They do also have a user assigned managed identity. That's not an option in the portal, but it is an option if you're doing it through ARM templates or the CLI. So yeah, always use system assigned managed identity or user assigned managed identity if you can. There's no need for the service principal method anymore. Next up, we have Kubernetes authentication and authorization. So inside the cluster, they have their own sort of role-based access control system. So like you can create users, groups, and then give those users and groups access to different aspects of Kubernetes. So different namespaces, different resource types. So like, say if I set you up as a user, I could give you access to a namespace called Gregor, but you can only list the pods. You can't edit the pods. You can't delete the pods. All you can do is list them. So by enabling role-based access control, that gives you that option. Otherwise, you've just got like one user which has full control over the whole cluster, which is fine if you're just a one-man band sort of person. But if you actually got different development teams, you can give each team a different namespace inside your cluster, and then you can use role-based access control to lock that down. The next one is the AKS Managed Azure Active Directory. So this, as we see here, basically controls access. Well, you can enable the integration with Azure Active Directory. So these groups we were just talking about, you can actually control that from Azure AD. So your on-prem AD, or if you still have an on-prem AD, can synchronize up to Azure AD, and then you got your one place to manage all your users, because that will then synchronize back down into your Kubernetes cluster. So if someone left, you only have to delete one user, and it deletes it from all systems, rather than having to remember, all right, that user is actually in my AKS cluster. I need to remove that as well. So it's quite a cool feature. So I always like to enable that. But just in this demo, I'm going to leave it off for now. We'll go into creating a more production-ready cluster probably in another episode. And then, obviously, because we are using VMs, we care about the encryption of the actual disks that are attached. So that's what this bit is here for. By default, it just uses encryption at rest with the platform managed keys from Azure. You can actually use your own custom keys, and then you can do all of this stuff. But unless you've got a real high security threshold and you have to do it to pass, SOC or something like that, just let it be the default one. It's so much easier. It makes like having to rotate the keys a lot easier. So next we have networking. So everything I'm saying so far makes sense?
Mm-hmm. Yep, all good.
Yeah, cool. That's good. So networking, we have two different types in AKS. We have Kubernetes, which is a standard sort of Kubernetes networking plugin. it will create its own VNet for you using default values and everything like that. Or we have the Azure CNI networking plugin, which was built obviously by Azure, and it sort of lets you bring your own VNet. You can use customizable addresses. You can actually, in future releases, different node pools can have different subnets, so you can actually do a lot more control. You can do peer into the VNet, so you can do so much more. So always use Azure CNI. It just gives you so much more flexibility going forward. But one thing to note is if you do use Azure CNI, every pod in your cluster will get an IP address on the subnet. And that's even if you haven't put a pod on your cluster, like for example, this one has 110 pods per node. As soon as I create this cluster, it's going to assign 110 IP addresses, even though the pods aren't there. So it takes it all up straight away. So make sure you plan your address space range so you can scale up. Because if I've only got 110, and let's say I had a /24, and that gives me 254 IPs or something, I could only scale to 2 nodes in that cluster. Yep. That's not good for production. So always plan it correctly, is what I'm trying to say here. So here, I'm just going to use a /16 because it's nice and easy. It gives me lots of IP addresses. So the cluster subnet will be on that. It's creating a virtual network for me. So I'm not going to actually create it, even though I'm using Azure CNI. It's just going to do it here. So I could have actually pre-built my own virtual network, and then I can actually just click in the virtual network box and just find one and use it instead. But we're just going to create one here. So that puts in the IP address range for the services. So this is the IP address range for the cluster. And then the services inside the cluster. So we went through services in another video. They're like an internal load balancer CNAME system. You can give it an IP range as well, which can be totally different to your external. So this is sort of internal to the cluster a bit. So here we just got a 10.0.0/16. It's a default option. And then inside we have I talked about the core DNS pods. So they live behind a service. And here you actually give it an IP address. So here I'm just using 10.0.0.10. So that IP address will never change, and that's what manages the DNS inside Kubernetes.
Okay.
And then we have this Docker bridge address. Always just leave that as default. It doesn't really matter, but yeah, as long as it's not any other subnet range and it's different to the other ones we've already picked, it's fine. Not sure if it's going to stay around because obviously Docker's now not part of Kubernetes, and they're making the Azure CNI better and more transparent. So I don't think this is going to be around for longer, but I could be wrong. And then obviously the DNS name prefix is just the name of the cluster --DNS. You can put that to anything you want, but as long as it matches DNS systems, then it's all right. It's sort of what's used for the hosted API, the control plane. So that's why you need it. Next up is the load balancer. So when you're creating it through the Azure Portal, you can only actually pick standard. If you're doing it through CLI or others, you can actually pick basic, but I prefer it's standard. It gives you more functionality. Never ever tick this box. I don't know why they still have it here, but it's not for production usage or anything. I wish they got rid of it. Yeah. And then we have security. So you can enable private cluster. So a private cluster basically means it's a cluster which has the master control plane non-accessible via the internet. So it's only accessible via your subnet. So that means you have to create a bastion host or a VM to manage that cluster. So if you really wanted that super secure, then tick that box. If not, then it's fine. And here, set authorized IP ranges. So you can use you can whitelist IP addresses that you own to only be allowed to access the API, the master control plane. So you can just tick that box and then put in a list of IP addresses in here. Right. Just because there's the demo again, we're just going to leave it off. And then network policies. So I'll leave it out so people can read it. But by default, every pod inside the cluster can talk to each other, which is good, but it's also bad depending on what you're doing. So with your network policies, you can actually create Kubernetes resources, either Calico or Azure, and they can say pod A can only talk to pod C. It can't talk to pod B, and it can only talk over port 443. But then it could say pod C could talk to pod A, and then via port 80. So you can just proper lock it down, and then there's going to be no cross communication. And if a pod for some reason does get hacked, it can't start talking to all the other pods, only the ones you've allowed it to.
Okay.
Sometimes, like in systems where you're using event-based architecture or message-based architecture, all your pods technically will probably never need to talk to each other. They only ever need to talk to that one single point. So you can lock it all down, and then they just talk to your message queue or your event grid. So that's where these come in very handy. So next we can go on to the integrations. So we talked about a container registry slightly in an earlier thing, but a container registry is where you store all of your container images. You don't have to use one in Azure. You can use Docker Hub or others. But if you had one, we could just pick it in the list, or you can create a new one. But just for this, we're going to leave it as blank. But what this does, it sort of connects the two systems together. So it uses that managed identity to have the right access to pull all the images from the container registry on your AKS cluster. Otherwise, you have to use something like pull secrets, and it can get messy because you've got passwords out in just base64. So if you're using Azure Container Registry, make sure you link it. You can always link it at a later stage, but if you're doing it all in one go, just set it up here. And then we have Azure Monitor. So you can actually do container insights, they call it, which is a preset of monitoring tools based off Azure Monitoring, and it links in a log analytics workspace. So if you have one, you can just pick one. So I got one here, so I could just pick that, or I could create a new one. And everything that happens inside the Kubernetes cluster and your pods get written to this log analytics workspace, and you can use custom query language to query the STD out of the container or the metrics. If it's got persistent volumes, you can base it off labels. You can do so much with it. So if you're definitely thinking about AKS in production, use container monitoring, the container insights. But for now, we're just going to disable that because I don't need to worry about that. Now, Azure Policy. So earlier we were talking about governance and how you can do governance. And this is where you can enable governance on your AKS cluster. So if you click enable, you can, by default, there's a few basic policies already available for AKS. So it's like, don't run my pods with privileged access and stuff like this. Make sure you never use the latest tag and all of that stuff for your container images. So if you're serious about governance, which I hope you are, click enabled, but you can enable this at a later date. So if you're not ready, it's fine. You can just leave it as disabled, and then you can go in later and enable it. But that's very important if you want that high level of governance. Next up is everyone's favorite, which they always say in demos that they leave, but we're actually going to put something in, and that's tagging. So I'm just going to use env for environment, and what have I got? And I've got test. So I'm going to tag it. So now I know that this is a test AKS cluster, and I'm fine to delete it. But it's so funny. Everyone always leaves tagging out in the demos, but they're so important.
Drives me out the wall, that, to be honest. And it's like, yeah, this is really important, but we'll skip this. And I'm like, no.
The best thing is you can set so many tags as well. So like, it's perfect. Just tag it. It helps with billing and cleaning up and everything. Just tag. But yeah.
So the way around that is to create an Azure policy that just appends tags anyway. So we should maybe demo that way.
Yeah, definitely. And then we just go to the review and create screen. And then
typically, how long does it normally take to do this? Is this quite a quick thing, or does it take?
So filling in the boxes, it could be as quick as you can type.
No, I mean, like when you click create, how long is that?
When I click create, it can vary. I've had it down to about 6 minutes before, but I've also had it up to 15. So we can check that. But basically, this just validates, checks everything I put in it is correct and it will work. So then we just hit create. and it will go off and start creating everything we need, which is quite cool.
And does it all go in one resource group? Because you know what it's like when sometimes you create resources, it starts creating network watcher and all that good stuff.
Yeah, so that's one of the downsides of creating it with the portal. You get this horrible resource group that starts with MC, which stands for Managed Cluster. I hate it. If you do it through, if you do it through the CLI and enable the AKS Preview CLI extension, you can actually name the resource group, so you can have it as -nodes, because usually all your VM scale set lives inside this horrible resource group. So yeah, we will be going through that in a separate video.
Yeah, that's one of my bugbears, when you've got nice naming conventions and then you end up with something like that. It's like,
yeah. Now you got to be careful though, because if you do have your Azure Policy set and you set your naming conventions via Azure Policy, this would actually fail because it won't match that. So
just going to mention
if you are trying that, yeah, just make sure you either disable it or put it in like just alerting. I think it's called alerting mode, isn't it, or something like that. But yeah. Hopefully we'll be able to actually name the resource group in the portal at one point. That would be really nice. But yeah. But basically,
network watcher used to annoy me. Network watcher RG, I was always like, oh, it's like all these nice naming conventions, and then boom, you've got this.
Well, by default, the log analytics workspace names are horrible as well.
So let's talk
default.
Let's talk questions here. Cost. What's this going to cost me at the moment?
Okay.
If this was running like for a day.
Cool. So basically, for the actual AKS control plane, it's nothing. Then you have the VM. So we've got one VM. So you'd pay the cost of the VM. So we had a D2 V2, I think it was.
Yep.
I can't remember exactly what they are, but they're quite cheap in comparison to some others. It's maybe £200 a month, maybe a bit more. Don't quote me on that. So divide that by 730 hours in a month, and then you get your hourly rate. And then you pay for the load balancer, so the standard load balancer. So you have to pay for that. And then you would also have to pay for the public IP address as well.
Okay.
So I can't remember exactly how much that is, but those little things all add up over time. So you've got to be careful about those. Even though they class AKS as a free service, you can't technically run it without paying for stuff, which is a bit naff.
Couple other questions I've got. Just jumping into my head there. So, is there any way to pause it or anything like that? Is there any way to stop it? Disable it?
So there is a sort of a way. In preview at the moment, it's called Stop Start Cluster. All it really lets you do is stop the nodes. So you're still paying for that public IP address, the load balancer, but you're not paying all of the node price. What it does is it takes all of the data and stores it up in the sort of the area where the control plane is stored.
Okay.
So it's like puts into I think it might even put into the etcd database, and it's there for about a year. So you can actually pause the cluster for a year, not paying your node resources, and then start it up again. Well, look at that. The cluster's actually just finished. That was very quick, which was good. Did you have any more questions? Or
no, crack on. So does the virtual machine keep running if you do that?
So if you stop the cluster, the virtual machine, the node will stop. It goes into like a deallocated state and everything.
Right.
But here, that's built already. So we can go to the resources. If I go on the right screen.
4 minutes, that took. That's a record.
That's really quick, yeah. It's probably because it's just one node. And here we get the nice overview pane of an AKS cluster. So here we can see we've got the tag value, which is awesome. We've got the Kubernetes services version. It tells you if it's Azure AD integrated. So it's a nice overview, tells you one node pool, the size, the API server address. So that's when you're doing any kubectl commands, it hits this this API server address. So that's like your master control plane name. Yep. I always find it funny that it says HCP in there and everything like that. I'm not sure why. It just I don't know what HCP stands for, so it's always tickled me. It's got network type, as we mentioned, Azure CNI. It's not private cluster. It's not got no pod cider. So one thing I didn't mention is if you use Kubernetes, it doesn't put the IP addresses on the subnet. It creates a virtual network that spans across the Kubernetes nodes, and you can specify what IP range. So it's like an internal virtual network inside the cluster. But because we used Azure CNI, you don't get that because they're living on the subnet. And then the other information we set, and then container insights, and it tell you which container application insight Azure Monitor workspace it is, and then you click it and it goes straight there. One cool thing here is if you wanted to connect to your cluster, you can hit connect at the top, and it's got some basic commands. So you can do AZ account set, sets your subscription, AZ AKS get credentials. But we can go through all that in another episode on how to actually connect to your AKS cluster and do things with it. Just really wanted to show you how to set one up as quick as possible so you can then start to play around. One cool thing in the Azure Portal, which is quite new, is this new Kubernetes resources. So by default, Kubernetes has its own dashboard. With the latest versions of AKS, that's actually disabled by default and not installed because they've built it all in here. So you can check your Kubernetes namespaces. We just got the basic ones. You can check your workload, so all your deployments and your pods, as we talked about in the previous one, and then these other different types of workloads, which we'll go into in other videos. Then the services, so we talked about that in the previous video as well. They're all in here. Ingress, which is something we're going to talk about in another one, but that's like a way to get into your cluster from the web, so for your applications. Storage, again, we'll go through this in another one, but you can see it all here. And then configuration, so your config maps, which is a way to store configuration for your pods. And then secrets, which stores lots of different secrets, but most of them will be in like base64 encoded, so you can really easily decode a secret. So I try to put everything in Key Vault instead, but like here you can see this is the that's the actual Decoder Secret. This is how easy it is to see it. It's just a certificate, and then by default it's just base64 encoded. So it's really cool that you can see that in Azure. And with the Azure AD integration, you can actually lock down who can see all of this inside the Azure Portal. So you can have it set as a group, and only the members of that group can see this stuff. So that's really cool. That means anyone who has access to the Azure Portal in your tenant can't see all your Kubernetes configuration and everything like that. Because you can actually click on the YAML file, and we're going to go more into YAML later, but you can actually edit this YAML file and make changes and then save it, and it will deploy to the cluster, which is really cool, really powerful, but scary as all it takes is one slight misconfiguration and can bring it all down.
That's not good.
No.
Okay.
But that's basically deploying an AKS cluster using the Azure Portal.
Okay, sounds good. Sounds good. Now, we probably have viewers who are PowerShell people and AZ CLI people. So, how about next up we cover deploying the exact same thing using PowerShell / the AZ CLI? That sound good?
Definitely sounds good to me. I know personally I haven't actually deployed one via the portal for a long time. Today was pretty much the first time in quite a few weeks.
And just for the purpose of explaining why is that? What's the reasons behind that?
Just because I've got a script and I can do so much more with it. I can check if resources exist, and I don't have to click a lot of boxes. I just type one command, it deploys my whole setup for me. I just sit back and relax.
So you've basically got you've almost got like an infrastructure as code type script that you can just wipe the whole thing and redeploy it.
Yeah, basically, and it checks to see if resources exist and everything like that. You can do it all with ARM templates or Terraform as well, but I just prefer the CLI because it's what I'm comfortable with. It's a lot easier to write than ARM templates, and you can pretty much get the same kind of result that as ARM templates with the CLI with a bit of PowerShell scripting and everything. Yeah, it's really cool.
So next episode, I'll probably write the CLI and you can keep it right.
Yeah, that sounds good to me.
Okay. Cool. So just for everyone watching the next episode, we are going to basically deploy the exact same resources using a bit of PowerShell and a bit of AZ CLI. And yeah, I think we'll just do that. Sounds good.
Yeah, sounds good to me.
Cool. Look forward to it.
Yeah, so thanks everyone for watching. This was episode 4. Please subscribe to the channel and give this video a thumbs up if you enjoyed it. Any questions or comments, please leave below or reach out to us on Twitter. And don't forget to click the notification bell to be alerted for the next video we upload.
Sounds good. Catch you in the next episode.